So I posted them in your class as well.
Perfect.
Okay, I'm ready.
So it was section 4.9, number 7 and 14. And it was just finding the antiderivatives.
Now I'm looking at it. If you give me a second, but I can solve your problem because I'm sure it's probably different. If you want me to solve this, if you want me to solve this, I'll solve this. If you want me to solve your problem, I'll solve your problem.
So it's f of x equals 3 root x plus cosine x.
So 3 like this?
Yep.
Okay. And what are we doing with this?
Finding capital F prime of x.
Okay, which means the most general antiderivative.
Yeah.
Because remember the notation is this. If I'm given f prime, I determine f. But if I'm given f, I have to determine uppercase f.
Okay.
So this was the first thing we talked about in 4.1.
That's called FTC, right?
Yes, this is in order to make sure that we understand what happens for the fundamental theorem of calculus. Yeah.
Gotcha.
Yeah. Okay, so first of all, what I would do here, I will rewrite it as 3x to 1/2 plus cosine x. So now 3 is a constant. I have to increase the power of 1/2 by 1. So it's 1/2 plus 1, which is 3/2. I have to divide by exactly the same number. Plus, which function prime is cosine, which is sine x, and I have to write c. It's the most general antiderivative. Yes, it needs to be cleaned up, and we're going to do that in a moment. But is this clear so far? Okay, so now I'll have to flip, and when I flip, this is 3 over 1 times 2 over 3, so this is just 2. And this, remember we had that discussion about 3 over 2? It's the square root of x to the third. So let me put a side note here. X to 3/2 is the square root of x to the third, and we really would like to see it like this, but even this one is fine. So it's up to you. You either write it like this, or like this, or like this. All three are the same. So if you want, it's this then, and then plus sine x plus a constant c. Remember, when it comes to indefinite integration, integrals that are indefinite, you can always go back and differentiate this, and you will get that guaranteed.
And that's just like checking your answer,
yeah,
correct?
Exactly.
Gotcha.
So when you bring down 3/2, and you will simplify with the other 3/2, and you still have 3, and 3/2 minus 1 is 1/2. And when you differentiate sine, it gets cosine, and you differentiate c, you get 0. So this is always the easiest thing in integration, because you have the power of checking available to you.
Sweet. Wait a minute. WebAssign said it's, I guess I have to write it.
Did you put it in? 2x the square root of x plus sine x plus c.
Yeah, why is it saying I got that wrong?
What are you entering?
I wrote 2x to like square root of x plus sine x plus c. I said I was wrong.
So did you write 2x the square root of x?
Yep.
And then plus sine x?
Yep.
Plus c?
Mm-hmm.
I may be crazy, I'm sorry, but maybe we have to write it, which is wrong. They should.
You have to write it the other way.
But that's you understand that it's wrong, not to accept this answer. You understand that?
Yeah. Oh yeah.
X to 3/2 is x the square root of x. It doesn't matter if you put it like this or like this. A WebAssign should accept the answer. That's why I have to see your notes when you take the test, right?
Right.
Because then you get credit. But maybe there was some other glitch in the system. Okay, next problem. You wanted 14, right?
Yep. And
So-
it was just find f, and it said f prime is equal to 8 square root of 1 minus x squared.
So f prime is, one more time, sorry.
8 square root of 1 minus x squared.
What I have, what I see here is a square. It's a ratio. Are you sure you have a product or a ratio?
Oh, shoot. That's 8 over.
Okay, be very careful.
Sorry, I missed that.
And they want us to find, no, they're telling us f of 1/2 is 3. So we are going to have.
Oh, could we do 8?
Oh, yeah, I'm sorry.
Like f of 1/2 is 8.
Of course, I'm sorry.
Yeah.
I'm just looking at my problem. I just copied it. Okay, so
No, yeah, you're good.
so what I was going to say is this will give us a unique function. It will not be a family of functions. It will not be the most general antiderivative. It will be the function that has the derivative this and also fulfills the given condition. Is that clear?
Yes.
Okay, perfect. So in order to find f of x, I have to ask myself, and 8 is 8, can wait patiently. I have to find which function I differentiate to get 1 over this.
Isn't that a was that sine?
Yes.
Oh, is it arcsine or cosine? Okay.
The one with minus in front is arccosine. The one with plus in front is arcsine.
Okay. Perfect.
Of course, plus a constant c. And now I have to plug in replace x by 1/2, and I'll get 8. So f of 1/2 is 8. Arcsine of 1/2 plus a constant c. Arcsine of 1/2, we know what that is. Which angle has sine 1/2? Is the smallest of the 3.
Wait, sine 1/2.
It's the small.
Wait, what was that?
Which angle has sine 1/2? And it's the first angle, the smallest of those 3 angles that we know everything about.
Oh, pi over 6?
Correct.
Or is it pi over 3?
Pi over 3 is not the smallest.
Okay. Sorry, I was confused by that question.
Okay, so let me just refresh your memory. So this is sine, this is cosine, and this is the smallest, this is the middle, and this is the larger. Always remember this is 1/2 and this is 1/2. This is the square root of 3 over 2, and this is the square root of 3 over 2.
Okay.
And this is the square root of 2 over 2 and the square root of 2 over 2. The smallest angle starts with 1/2. The largest angle ends with 1/2.
Oh, that bottom one should be pi over 3, right?
Oh, yes, of course.
There we go.
The largest angle ends with 1/2. The smallest angle starts with 1/2. So I will simplify by 2. So then c equals 8 minus 4 pi over 3. And now I have the function, which is 8 arcsine x plus this. If you want to write it as one fraction, which I would recommend, it's 24 minus 4 pi. Very good. Next question.
Sorry, I'm just writing this in real quick. Yeah, that's right.
Is that okay?
Yeah. Yeah, I just typed it in. And it was totally fine. Let's see. I have the
Yes.
final. Oh, what did you guys go over last night in that class?
There were questions from the previous final. There were questions from test 4 that I posted. I can show you. I have it here.
Well, no, I just didn't want to. I just wanted to kind of stay on that topic with those. Because do you think it'd be better to go over test 4 or the final?
It's up to you. You
I have
and
them both printed for me.
you and Tara are the boss. So this is what we covered last night. Something from 5.1, from 5.2, one of the problems at the end, very end, 16. Some limits, a limit from the previous final. The first problem from the previous final. What else? The approximation of sine 46 degrees using differentials. Implicit differentiation. This one from the previous final. Another limit in which we rationalized it was infinity minus infinity. Another limit from the previous final. A chain rule from the previous final. Problem with the inverted cone.
Gotcha.
With the cone, not the inverted cone. With the cone with the pile of sand. We did that again. Yeah, and then this was another problem of approximating using subintervals. But it doesn't matter. We can do any problem.
Could we do from test 4, the review one you posted? Number 4, it's a 60-point question, but it has like A, B, C, D, E, F.
Yeah.
Could we do those?
Yeah. Just choose what. Do I turn off WebAssign now?
Could you leave it open just in case
I'll leave it open.
I go over that? But for right now, could we do those ones?
Yeah, just tell me.
Just integral ones, but
just tell me which one.
Okay. Letter A.
And I didn't have that up. I'm looking right now.
Oh, also, I meant to ask you, because WebAssign, all the homeworks are due this weekend, right?
Yeah, before the test. That's the whole purpose. If you want to go back and redo something, you still can till Monday, Tuesday. But I have to turn in the grades by Tuesday.
No, yeah, that's fine. For some reason, it won't let me go back to the past WebAssigns.
Oh, really?
Yeah, because it says, like even for section 5, it says it expires tonight at midnight.
Oh yeah, I see it. Reschedule assignments, okay. Let me just, thank you for pointing that out to me. And I'm gonna do it right this moment. Multi-select. Okay. I'm going to add, today's the 12th, I'm gonna add 9 more days, 8 more days. And I selected everything and I applied to, let me know. Date conflicts are indicated below. Okay, let's see which one is a date conflict. I don't see any date conflict. Okay. Okay, let me know now.
All right, let me check.
It didn't give me any problem now. Oh, wait, just 1 second. I'm going to set the date because it does not allow me to add date available to. If it doesn't allow me now, I will do it after class. I don't want to waste our time.
Okay. No, yeah. I just wanted to make sure I told you that.
Yes. And once I have you on the phone, in Zoom, I would like to check and make sure that this is okay, it's working, and it changed everything. But if it gets complicated and gives me silly error messages, then it says saved. So now try again if you'd like, or let me know if it's. Oh no, it didn't change anything. Oh,
yeah,
maybe.
it's still saying it expired last night.
Yeah, I changed everything.
Huh.
For the past ones and for the future ones as well.
Mm.
Okay, I think it allowed me right now. Will you double check?